actually post, there'll be 2 video links for this. Okay, I'm not sure what all these messages are here. Anyway, I'm going to get restarted here with sharing. So hopefully you're seeing we're back on number 17, and we're continuing. Anyway, this will be recorded in a second video. I'll have both links up. Sorry about the interruption. So when we got interrupted, we were formulating the area. We were formulating the area here. We got a repeat message here. Anyway, we were reformulating the area, and we had the rectangle on the left here, the length times the width, and we had this expression, this new expression for the y. And then I was just about getting to adding the area of the semicircle, and that's what I did in the top right corner here. A circle is pi times r squared. R in this case is half of x. This is x, so that's why it says pi times x over 2 squared. But because it's a half circle, I had to divide it by 2. Well, when you square x over 2, you get x squared over 4. And x squared over 4 times pi divided by 2 all comes out to pi x squared over 8. This thing right down here in the corner. That's I know I got too many colors here, but right down there, that's my area. So now I got my semicircle and my rectangle added together. Well, I got to do some multiplying, so I multiplied x by this quantity. And then I didn't have to do this, but I rewrote the expression right here, putting these 2x squared terms into 1. That would not have had to be done, but I did it. Okay, now finally it's time to maximize the area of the window. So take the derivative. Derivative of 8x is 8. Here I need to take, the power rule, 2 times that thing in parentheses times x to the first power. And then on the right, when you do the power rule on the last term, 2 times pi over 8 is pi over 4, and reduce the power by 1. Here I just multiplied out the -2 times that quantity. It gave me that. And then, all right, I got it equal to 0 over here, and I just I need to solve for x. So I got the 8 out of there, and I multiplied this out. It gave me that. Let's see. All right, what I did in this term is negative over 2x, so positive pi, so it's negative 1/2 pi x plus positive 1/4 pi x, which turns out to be I just combined these two terms into one, negative 1/4 pi x. And then finally, I factored an x out and divided both sides. And, well, I mean, a little bit awkward, but here's the expression for x. X needs to be, when you figure it out, about a little bit under 4.5 feet. And the height, figured out over here, is that expression, which turns out to be about 2 1/4 feet. So, a lot of horsing around getting that one set up. That's what made that one harder. I don't know if we have any more follow-ups to that, but that was number 17. So I got about 15 text messages, and they all say go through. Oh, I do number 11. Thank you. I have another request. Okay, I better go take a look at my messages here and see if there's some others there. Excuse me just a second. With all the confusion of me kind of hanging up on you, that, by the way, my web page crashed, and that's why we had nothing. Okay, number 11 is the next request. Thank you for that request. Number 11. All right, number 11 reads, find the length and width of the rectangle that has the given area and a minimum perimeter. So in number 11, they gave us the area of 64. So I just sketched out a rectangle that had a width of W and length of L, and I wrote in inside the box the area of 64. So, I mean, length times width equals 64. But you know by now we don't want two variables. So I solved for W so I could put everything in terms of L. So here's a new name for W. Okay, and then what do you do when you find perimeter? Let's see. Should I be... Okay, I want to just double check here. Number 11. Minimize the perimeter. Okay, I really should have... I see I didn't double that. So I should have written 2 lengths plus 2 widths equals my perimeter. I'm just going to call it function of L, you know, just a new. So now I've got my function. This I can rewrite this. 2 times 64 is what? 128 over L. Okay, now let's take the derivative. So when you take the derivative of 2L, you get 2. Here we use the quotient rule. Derivative of a quotient is the denominator times the derivative of the numerator, which is going to be 0. So let me erase that. Minus, so I should erase the plus too, minus the numerator times derivative of denominator, minus denominator, I'm sorry, numerator times derivative of denominator. Minus, okay, I got goofed up here. Denominator times derivative of numerator minus numerator times derivative of denominator, which is 1, over denominator squared. So we're down to 2 minus 128 over L squared equals our derivative. Okay, scroll down here. We got to get some space. All right, we need to set that equal to 0. And now what? Let's multiply both sides by L squared. Be careful, this is a little different because I have 2 things to multiply by on the left, right? Everybody get that? If I multiply the whole equation through by L squared, that'll be 2L squared minus 128, the L squareds cancel there, equals 0. And now we can just do the algebra, get 128 on the other side, divide both sides by 2. So the length is 8. And if the length is 8 and the area is 64, doesn't the width have to be 8 too? So again, no shock. We ended up with a square. Was there a label in that one? Yeah, it was square feet. So these are feet. 8 feet by 8 feet. Excuse me. So there's the other request I got, number 11. Are there any others you would like me to work on? And I'm sure there could well be, but I haven't heard of any. I haven't heard from you guys yet. And hey, again, I want to thank all of you for hanging in there. I got to just go back and see if I can find my mouse here. I just got to go back and see. Yeah, we have the same group hanging in here. Okay, got a message, number 13. All right, thank you. We will look at number 13 next. And I'll turn the pictures back off. Okay, number 13. Here we go. Having trouble locating the mouse. There we go, number 13. Oh yeah, this one's a little different. Thank you for asking about this one, because this is the only time we've had kind of like two things up against each other. So instead of just a square or a rectangle, we now have 3 vertical lengths. So I'm glad you brought one up. So you see my drawing there. It says a rancher has 200 feet of fencing, and he's got to make 2 adjacent rectangular corrals. They have a figure in the book. Now this is my crude drawing up on the top there. What dimensions should be used so that you can have the biggest area enclosed by the fencing? So the first thing we got to, this is very important, we are limited by a perimeter of 200 feet. And so what I did is I called each of these equal lengths here X, and then I called the vertical length Y. Okay? But again, we can't use 2 letters. So how can I solve that? Well, I mean, here's another way to express Y. We got a total of 200 feet. Why did I take off 4x? Because won't there be one, there'll be 2 on the top and 2 on the bottom. There's 4 x's altogether in the perimeter. So 200 minus 4x, and why did I divide by 3? Because there are 3 of those guys. There's 3. This is what's different about this. There are 3 heights, so to speak. Okay, so here's my new name for Y. Okay. So now that I have that, we can jump down to here. So what's the area of the rectangle? Length times width. Do you see why I called it 2x? Because the length is, there's x in there twice. So it's 2x times that new height, that new w, that new y we just came up with. So there's the expression of our area, which I simplified. I multiplied everything through by 2x. 2x times 200 is 400x. 2x times negative 4x is negative 8x squared. I hope you can see that there on the top. And we still have that 3 on the bottom. Okay, then I split it up. If we have 2 terms divided by 3, you can also kind of go backwards and write it at each term over 3. So that's what I did over here. So 400x over 3 minus 400 thirds x minus 8 thirds x squared. Okay, now it's, from here on in, it's not bad at all, because now we can find the derivative. The derivative, easy power rule. You just get the coefficient for the first term, 400 thirds. For the second term, power rule. 2 times negative 8 is negative 16 thirds times x. Set it equal to 0. Solve for x, and you get x equals 25. It's a little bit of a mess. You got to go back and find y. So what you do is you come here. Remember, that was the expression that we used for y. So now just plug 25 in there. What's 4 times 25? 100. 200 minus 100 is 100. And what's 100 over 3? 33 1/3. I forgot. Was there a label here? This is which one? Number 13. Yeah, these are feet. So for the dimensions, I mean, I guess you could say what? The pen is 50 feet by 33 1/3 because X is, there's two of them. So it says what dimensions should be used. I mean, each pen would be what I've got down here, 25 feet by 33 1/3. If you look at the whole thing together, then it's 25 times, you know, it's 50 feet by 33 1/3. So that is number 13. Thank you for the request. Is there any other one we should look at? I like somebody else talking to one of the students ahead of the session today, and probably setting up the problems, making a drawing, a sketch of some kind, setting up your variables, getting it down so you only have one variable, and finally getting your expression for whatever it is you're supposed to minimize or maximize is probably the hardest part of the problem. I'm guessing the derivative and setting the derivative equal to 0 and solving, that's probably the easiest part, isn't it? I think, from what I'm hearing from students, and I can see why. Okay, any other requests? I think I did them all. Let me know if I didn't. We did 3, 21, 17, 11, and number 13, I believe. We looked at all of those. Sorry about dividing the video into two parts. So this week you're going to get 2 links. I'm going to just list them right next to each other with the same date, today being the 19th. I'll put them both on your web page. Fortunately, unless I can figure out a way to paste them together, I might be able to do that. If I paste them together, then I'll only put one link. Okay, other questions? Put them in the group chat, or send me a text message, or just open your mic up and ask away. So I don't know, some of you may have missed the announcement ending, so I'm going to repeat that. No new assignment. I mean, we didn't do any new lesson. We continued our discussion and problem solving on optimization. Tomorrow's class, I'm going to give a presentation. So I would like you to take notes on that. Okay, something coming through on the messages. I would like you to take notes on that. Let me check my message. I think I got another problem here. Number 15. Thank you. Number 15. We will work on that one next. Number 15. Okay, so let's go there right now. Number 15. All right, now I'm assuming, I mean, the only one that's really interesting is part C. So, I mean, part A, I shouldn't say that's not interesting, but I figure this is a geometry class, and how do you find the area of those? You take the area of the base times the height. So that first one is 9 times 11, 99. The second one over in the book, area of the base is 25. 25 times 5 is 125. I mean, you probably weren't asking me about A or B. But C is the calculus one, where it says, determine the dimensions of a rectangular solid with a square base of maximum volume if its surface area is 150. Okay, so here's that. Here's 15. So it's 15C that I'm going to go through. Here's my sketch right next to there. And you notice I made a square base. I've got both dimensions of the bottom being x by x, just like the book said, make the base a square. And then so again, you got to take the area of the base times the height to get the volume. But what they gave us was the surface area. So I should really divide this up here. This whole part here is just for finding the surface area. Okay. The surface area they told us was 150. Well, what's the surface area? That's the bottom and the top. Here's the bottom and the top. X squared on the bottom, x squared on the top. And then isn't each side piece x by h? And since there's 4 sides, so we got bottom and top added to sides, and that comes out to 150. Well, you notice we have 2 variables here, x and h. Again, we can't have 2, so we got to get rid of 1, so I decided to get rid of the h. So I went about solving the equation for h. First I subtracted 2x squared from both sides, then I divided both sides by 4x. So actually I even got it down to here. So now I have a new way to say h. Alright, we got our height. Now, back to volume. That's over on this side. How do you find the volume of this? You take the area of the base and multiply it by the height. Here's the area of the base, and here's that height that we just figured out from over there. Okay? That's our volume. So then I just multiplied that out. I took x squared times 70. Hang on a minute. Oh, I see. I rewrote it. I got to think this through here. What did I do there? Height is right there. Oh. Oh, okay. So here's a simplified version of what's to the left there. I mean, what's x squared over 2x? I canceled the x's. So here's a simplified version of what's to the left of it. Okay, now multiply x out. X times 75, 75x over 2, and then minus x cubed over 2. And now finally I can take the derivative. It's pretty straightforward. I rearranged the terms, but it's a power rule. Bring the 3 down, negative 3 over 2 times x squared plus 75 halves. Set it equal to 0 and solve. And I found out the x dimension has to be 5. And then if you plug that back in over here, you can find out, not too surprisingly, the height is 5. So in other words, this turns out to be a cube. X by x, so it's 5 by 5 by 5. And these are all inches. I should put the label down, inches. So the final question there was, determine the dimensions of the solid. Well, every dimension is 5 inches. So that was 15C. I'll check my messages again. We'll see. Right now it appears that that's all the requests I have received. Anybody else? Other questions you'd like to see? So we got a pretty healthy number in today. 1, 2, 3, 4, 5, 6 fairly long ones. Good. Thank you for the requests. I mean, we can continue the discussion, but most of tomorrow I want to devote to that presentation. Okay, not hearing any, I'm going to call this quits. I am going to make an attempt to paste these 2 videos together. And but if I don't, I will post both of them. Thank you. Appreciate it. I will see you tomorrow.